The ozone layer is a layer of ozone high in the atmosphere, in the stratosphere, that filters out the high-energy UV radiation emitted from the sun. We wouldn't be able to live on this planet without that ozone layer.
Our business is monitoring the pulse of the planet. We do this by taking high-quality observations of atmospheric composition, specifically greenhouse gases, ozone, ozone-depleting gases, aerosols, and surface radiation.
The Montreal Protocol was an agreement all countries of the world signed on to in the late 1980s in order to essentially save the ozone layer, to eliminate the production of ozone-depleting gases around the world.
F11 is chlorofluorocarbon 11. Production of this compound was slated to be banned by the Montreal Protocol back in 1987. In 1996, we watched its concentrations go down in the atmosphere because we were no longer using it for all of those things that we were using, for the refrigeration, for the air conditioning, even for hairspray in the early days.
F11 was meant to be phased out globally in 2010. 3-4 years after that, we saw the concentration decline slow down, and we did not expect that at all. We spent a number of years trying to figure out why, because to me, it was entirely unlikely. Was somebody really violating the protocol?
When you see it depart, the first thing you question is your instruments. The next thing you question is your calibration gases. The next thing you question is everybody around you. You want to make sure you've got this right. The next thing is this a global phenomenon? Is there some change in circulation that would slow down the decline of F11, something that would change its lifetime in the atmosphere?
And so it took us some time to understand exactly the ramifications of the results and to pinpoint that actually it was an emission increase, and furthermore, it was likely to be due to new production since the 2010 ban in violation of the protocol.
The next question is, where's this coming from? And so by looking at our global network and where our sites are located, we could pinpoint it to Southeast Asia.
All of a sudden, there was an enhancement and a variability for CFC11 in pollution plumes that were reaching Hawaii. That told us that some place upwind of Hawaii was likely the source of at least some of this emission increase.
Since then, we've brought in some additional measurements, and folks have looked at those, and it's pretty convincing that it was coming out of China.
There was a big response internationally. United Nations Ozone Secretariat, the folks who were in charge with revisiting the issue of the Montreal Protocol and ozone depletion, had a meeting in July of 2018, and the CFC11 issue took over discussions because they were so concerned. They're considering changes to the Montreal Protocol itself to ensure that this kind of thing doesn't happen again. There were a large group of folks involved in bringing this study together. They were both from NOAA's Global Monitoring Division and Chemical Sciences Division, and CIRES, the Cooperative Institute for Research Environmental Sciences, and then a number of colleagues from Europe, both from the UK and from the Netherlands. It feels really good to be part of this team that was able to use the measurements that they make and provide actionable information to hopefully limit the damage to the ozone layer that this increased emission and production would have caused. If we decrease those concentrations, because the ozone layer and the ozone there is constantly being produced and destroyed, it will heal itself and reestablish itself.